Eastern Front, December 19th, 1943. Temperature minus 38 degrees Celsius. Inside Oberfeldwebel, Klaus Richter's Panther Ausf, a condensation from his breath freezes instantly on the steel gun sight. Ice crystals accumulate in layers across every surface of the fighting compartment, transforming the 44-ton machine into a metal tomb. The engine behind him refuses to start despite 3 attempts with the electric starter. Battery voltage has dropped from 24 volts to 17 in the pre-dawn cold. Richter's gloved hands, already numb through wool lining, adjust the manual turret traverse that has seized solid from lubricant crystallization overnight. The Maybach HL 230p30 engine, which generates 700 horsepower in temperate conditions, now struggles to turn over at all. Transmission oil has thickened to the consistency of tar. The final drive units, already weakened by design flaws that plagued early Panthers, face impossible stress from cold that exceeds all engineering specifications. Through his periscope, Richter watches a T-34 model 1943 move across the frozen landscape with fluid ease. Wide tracks distribute the Soviet tank's weight across snow that would bog down German armor. The diesel engine starts reliably using compressed air bottles maintained at 60 atmospheres specifically for winter conditions. While Richter's crew burns precious time attempting to coax life from their frozen systems, Soviet tankers maneuver with confidence across terrain their machines were designed to master. His loader, Gefreiter Hans Weber, struggles with ammunition that has become dangerously unstable at extreme temperatures. The 75mm KBUK 42L70 shells, each weighing 15 kilograms, must be handled carefully. Metal components contract at different rates in severe cold, creating stress fractures that could cause catastrophic failures during firing. The Panther's superior gun, capable of penetrating T-34 armor at ranges exceeding 1,500 meters in normal conditions, becomes unreliable when operating parameters collapse in Russian winter. The driver, Unteroffizier Schmidt, finally achieves ignition after their 4th attempt. Black smoke pours from the exhaust, indicating incomplete combustion from fuel that has partially gelled despite additives. The engine runs rough, misfiring on multiple cylinders as frigid air overwhelms the carburetor system. Engine temperature gauges remain in the red zone, warning of thermal shock that could crack cylinder heads or seize pistons outright. Richter's tactical situation deteriorates before the Panther even moves. Radio communications fail as electrical systems struggle against cold that drains battery efficiency by 60%. The 10-watt Fu-5 radio, already inadequate for coordinating panzer operations across the vast Eastern Front, cannot penetrate atmospheric interference at these temperatures. German tank crews fight isolated, unable to call for support or coordinate with infantry elements supposedly protecting their flanks. Driver, advance slowly. Keep engine RPM below 2000. Richter orders through the intercom, knowing that higher speeds will accelerate mechanical failure. The Panther lurches forward, tracks breaking through snow crust that reformed overnight into ice. Each meter of movement comes at tremendous cost to components designed for a much lighter 35-ton vehicle, not the 44-ton reality created when Hitler demanded additional armor protection during prototype development. The final drive begins its death spiral within the first 100 meters. Weakened gears, undersized for the Panther's actual weight, grind against each other with forces amplified by cold-thickened lubricants. The characteristic whine of stressed metal echoes through the hull, a sound every Panther crew has learned to dread. At Kursk in July 1943, Panthers suffered catastrophic final drive failures at rates exceeding 40%. In this December cold, the mechanisms face even greater stress. Through his commander's cupola, Richter spots 3 T-34 seconds advancing across his front at intervals, suggesting coordinated movement. Soviet tactics have evolved dramatically since Barbarossa. These are not the confused, poorly led formations of 1941. These tank crews communicate via radio, maneuver in mutual support, and understand that their numerical superiority, combined with mechanical reliability, creates decisive advantages. The nearest T-34 moves at 20 km per hour across frozen ground, its wide 500mm tracks providing ground pressure distribution that allows rapid movement. Richter's Panther, limited by transmission and final drive concerns, can manage perhaps 15 km per hour before mechanical failure becomes inevitable. The tactical mobility advantage belongs entirely to the Soviet armor, inverting the assumptions German doctrine had held about panzer superiority. Gunner, target left, T-34 at 800 meters, Richter commands. Weber begins the laborious process of loading a 75mm armor-piercing round. The manual turret traverse, its hydraulic system frozen solid, requires tremendous physical effort to move. Each degree of rotation demands full-body effort from the gunner, who must crank the mechanical system, while the commander attempts to keep the target in his sight. The T-34 fires first. Its 85mm ZSS-53 gun sends a shell that strikes the Panther's frontal glacis plate at 55 degrees of slope. The round deflects upward, the angled armor performing exactly as German engineers predicted, but the impact sends shock waves through the hull that crack ice formations and shower the crew with frozen debris. The psychological effect proves as significant as physical damage. Richter's gunner finally achieves target alignment. The squeeze of the firing mechanism sends the 75mm round downrange at over 900 meters per second. The shot strikes the T-34's sloped frontal armor and penetrates, testament to the Panther's superior gun penetration. The Soviet tank shudders to a halt, smoke billowing from hatches as the crew evacuates. One kill against odds that grow worse with each passing moment. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But 2 more T-34 seconds appear from concealed positions, their movement suggesting these Soviet crews have learned to coordinate attacks rather than presenting isolated targets. The Panther's limited turret traverse speed, already compromised by frozen systems, cannot track multiple threats simultaneously. Soviet tankers exploit this weakness systematically, forcing German crews into impossible tactical dilemmas. The second T-34 maneuvers to the Panther's left flank, taking advantage of the German tank's narrow 40mm side armor that offers far less protection than the 80mm frontal plate. Soviet commanders have studied captured Panthers extensively. They know exactly where these machines are vulnerable. The 55-degree slope that makes frontal attacks difficult becomes irrelevant when attacking from angles where German armor protection sacrifices thickness for weight savings. Schmidt attempts to pivot the Panther to present frontal armor to the flanking threat. The transmission protests with grinding sounds that indicate terminal stress. The final drive's already weakened gears, forced to execute a turn that generates maximum torque loads, begin to disintegrate. Metal fragments circulate through the transmission fluid, accelerating damage to every component in the drivetrain. Richter watches his tactical options collapse in real time. The Panther, supposedly Germany's answer to Soviet armor superiority, has become a liability rather than an asset. The temperature that freezes lubricants, drains batteries, and stresses every mechanical system transforms Germany's technological marvel into a 44-ton anchor that cannot maneuver, cannot retreat, and increasingly cannot even defend itself effectively. The flanking T-34 fires at point-blank range. The 85mm shell penetrates the Panther's side armor like paper, entering the fighting compartment at an angle that sends fragments ricocheting through the confined space. Weber collapses without a sound, his torso opened by jagged steel that painted the turret walls with crimson mist that freezes almost instantly. The loader's position sits empty, except for torn fabric and spreading stains that will never wash out of the steel flooring. Schmidt's voice crackles through the intercom from the driver's compartment, panic evident even through equipment that distorts human speech into mechanical approximation. Final drive failure. We're immobilized. Transmission is seized. The Panther that was supposed to dominate Soviet armor has traveled less than 300 meters before catastrophic mechanical failure ends its combat effectiveness permanently. The final drive units, designed for a 35-ton vehicle but forced to cope with 44 tons plus the additional stress of extreme cold, have disintegrated completely. The tank that German propaganda called invincible sits motionless, unable to maneuver, unable to retreat, and increasingly unable to survive the engagement it can no longer control. Richter makes the decision that defines every German tanker's nightmare on the Eastern Front. Bail out. Abandon tank. Take wounded and essential gear. The crew begins the desperate process of evacuating their disabled machine. Richter drags Weber's body toward the commander's hatch, knowing that leaving the dead enemy capture violates every principle of unit cohesion. But the Soviet tanks are closing, and staying means dying in a frozen metal coffin that has become a tomb rather than a weapon. As Richter pulls himself through the hatch into air that burns his lungs with every breath, he understands the fundamental failure of German armor doctrine. The Panther was engineered for European warfare, not for the extremes of global conflict that political decisions had forced upon the Wehrmacht. Every sophisticated system aboard this tank, from the complex transmission to the precision-machined final drives, has proven inadequate when confronted with environmental conditions that exceed all design parameters. The surviving crew members scramble across frozen ground toward German infantry positions 400 meters distant. Behind them, their abandoned Panther sits motionless, a monument to the disconnect between engineering excellence and tactical reality. The T-34 seconds that killed it were simpler, cruder, and far less sophisticated. But they were designed for the war they actually had to fight, not the war German engineers had imagined. December 19th, 1943 marked the beginning of Klaus Richter's education in the brutal arithmetic of the Eastern Front. Superior firepower meant nothing when mechanical failure prevented engagement. Advanced armor protection became irrelevant when cold weather turned every component into a liability. The Panther that was supposed to restore German armored superiority had instead revealed the fatal flaw in prioritizing technological sophistication over operational reliability. The reality of tank warfare in Russian winter had nothing to do with ballistic calculations or armor penetration charts. It came down to simple questions. Could your engine start? Would your transmission survive the first 100 meters? Could your crew operate effectively while their equipment betrayed them? For German Panther crews facing Soviet T-34 seconds in -40-degree cold, the answers to these questions determined survival or death long before the first shot was fired. The frozen steppes of Ukraine, January 23, 1944. Hauptmann Friedrich Becker commands a company of 8 Panthers from the 2nd SS Panzer Division Das Reich. His orders specify holding a defensive position against Soviet armor advancing toward the Dnieper River crossings. Intelligence reports indicate at least 30 T-34 seconds approaching his sector, outnumbering his force nearly 4-1. Becker's experience with Panthers spans 6 months of continuous combat. He knows intimately the mechanical vulnerabilities that plague these tanks. At the Kursk offensive in July 1943, his unit watched 50% of their Panthers break down before reaching the first preparation area. 2/3 of those failures stemmed from engine problems, 1/3 from transmission and final drive issues that would only worsen as winter approached. The temperature reads -35 degrees Celsius at dawn. Becker's crews have spent the night running engines periodically to prevent complete freezing, consuming precious fuel they cannot easily replace. German logistics on the Eastern Front have deteriorated dramatically since Stalingrad. Supply convoys face constant partisan attacks. Rail lines suffer sabotage. The fuel that does arrive gets diverted to infantry units desperately defending against Soviet winter offensives. All units report operational status. Becker transmits via radio, knowing the answer before responses arrive. Panther 2. Final drive damaged during night movement. Limited mobility. Panther 4. Transmission temperature warning. Cannot maintain sustained operation. Panther 6. Engine failed to start. Working to resolve. 3 of 8 Panthers report mechanical issues before the enemy even appears. This represents the operational reality of Panther deployment in winter conditions. No amount of crew skill or tactical brilliance can compensate for equipment that fails systematically when temperatures exceed design parameters. The 37% operational readiness rate that plagued Panthers throughout 1943 persists into winter, where cold amplifies every existing mechanical weakness. Through his binoculars, Becker watches the first wave of T-34 seconds crest the ridgeline 2 kilometers distant. They advance in coordinated echelons, maintaining mutual support distances that prevent isolated engagement. Soviet tactics have evolved dramatically. These are not the confused mass attacks of 1941. These tank crews have learned to exploit terrain, use suppressing fire, and concentrate overwhelming force against specific points in German defensive lines. The T-34 seconds move at sustained speeds exceeding 20 km per hour across frozen ground. Their wide tracks provide ground pressure distribution of 0.65 kilograms per square centimeter, allowing rapid movement across snow and ice that would immobilize narrower-tracked German armor. The Panther's ground pressure, despite its sophisticated torsion bar suspension, exceeds 1.4 kilograms per square centimeter, nearly double that of Soviet tanks. Becker's Panthers occupy prepared defensive positions, hull down behind earthworks that expose only their turrets and guns. In theory, this provides maximum protection while allowing engagement at the Panther's optimal long ranges. The 75mm K/K-42 gun can penetrate T-34 frontal armor at distances exceeding 1,500 meters, creating killing zones where Soviet tanks should die long before closing to effective range. Theory collapses when confronted with mechanical reality. The first Panther to engage, commanded by Lieutenant Hoffmann, fires 3 rounds at a T-34, advancing at 1,200 meters. The first shot misses when the frozen manual turret traverse cannot track the moving target smoothly. The second round strikes but deflects off the T-34's sloped armor, the angle of attack not optimal for penetration. The third shell jams in the breech as thermal contraction creates tolerance issues between ammunition and firing mechanism. While Hoffmann's crew frantically works to clear the jammed round, the T-34 closes the range to 800 meters and fires. The 85mm shell strikes Hoffmann's turret mantlet, a known weak point where the curved gun shield can deflect rounds downward into the thin 16mm hull roof. The penetrating shell ricochets inside the fighting compartment, killing the gunner instantly and wounding the commander. Hoffmann's Panther is knocked out without achieving a single kill, victim of equipment failure rather than enemy superiority. Becker watches Soviet armor exploit the gap created by Hoffmann's loss. T-34 seconds pour through, flanking the remaining Panthers while suppressing German infantry positions with machine gun fire. The tactical situation deteriorates with shocking speed, demonstrating how mechanical failure cascades into operational disaster when facing an adaptive enemy. Panther 5. Engage targets at 600 meters. Panther 7. Cover the right flank. Becker orders, attempting to coordinate a defense that grows increasingly hopeless. Panther 5, commanded by veteran Oberfeldwebel Klaus, achieves 2 kills in rapid succession. His gun crew has mastered the intricacies of operating the 75mm weapon in extreme cold. They pre-warm ammunition near the engine compartment, maintain meticulous timing between shots to prevent thermal shock, and compensate for the sluggish turret traverse through anticipation and skill. But 2 kills mean nothing against 30 attackers. For every T-34 that burns, 2 more advance to replace it. Soviet tank production in 1943 averaged 1,300 T-34 seconds per month. German Panther production during the same period averaged 148 tanks monthly. The arithmetic of attrition favors the side that can replace losses faster than they accumulate. Panther 7 attempts to reposition, exposing its vulnerable side armor during the maneuver. A flanking T-34 fires at 300 meters, the 85mm shell penetrating the 40mm side plate and detonating ammunition storage. The explosion tears the turret from its ring, sending it spinning through the air before it crashes 10 meters from the burning hull. Secondary explosions cook off remaining rounds, ensuring no survivors and no recovery of the disabled vehicle. Becker's company has lost 3 Panthers in less than 15 minutes of engagement. The survivors face impossible odds against an enemy that can afford to trade losses at rates that would cripple any German unit. Soviet doctrine explicitly accepts high casualties when tactical objectives require aggressive action. German doctrine has no answer for an opponent who can sacrifice 5 tanks to destroy 1 Panther and still maintain offensive momentum. The operational mathematics become stark. Germany produced approximately 6,000 Panthers total between 1943 and 1945. During the same period, Soviet factories manufactured 29,400 T-34 85 seconds alone, not counting the thousands of 76mm gun variants also in service. Even if Panthers achieved kill ratios of 4 or 5 to 1, which represents optimistic estimates, strategic defeat remained inevitable when facing such disparate production capacities. Temperature continues dropping as afternoon transitions to evening. -40 degrees Celsius now, the threshold where diesel fuel begins to gel without additives. But T-34 crews have procedures for extreme cold. They mix tractor kerosene with diesel fuel at prescribed ratios. 10% kerosene for -20 to -30 degrees. 25% for -30 to -35 degrees, 70% kerosene for temperatures below -35 degrees. These solutions developed through bitter experience during the 1941 winter counteroffensive, when Soviet forces first encountered the reality of mechanized warfare in extreme cold. The compressed air starting system, the wide tracks, the simplified mechanical systems all emerged from practical lessons rather than theoretical engineering. Soviet tank design prioritized operation under actual battlefield conditions over technical sophistication. German engineering took the opposite approach. The Panther represented cutting-edge technology, sophisticated systems, and precision manufacturing. The Maybach engine generated impressive horsepower from a compact V12 configuration. The transmission offered multiple gear ratios for tactical flexibility. The final drive used planetary gear sets for efficient power transmission. But sophistication became vulnerability when temperatures exceeded design parameters. The compact engine overheated in summer and froze in winter. The complex transmission required constant maintenance and failed catastrophically under stress. The final drives, undersized for the Panther's actual weight, disintegrated within hundreds of kilometers of operation. A captured Panther, examined by Soviet technical intelligence in August 1943, revealed the fundamental contradiction in German design philosophy. The armor was excellent, the gun superb, the optics world-class, but operational reliability, the single most important factor in sustained combat effectiveness, had been sacrificed for performance specifications that rarely mattered on actual battlefields. The report noted that while a Panther could theoretically destroy T-34 seconds at extreme range, most tank engagements on the Eastern Front occurred at distances under 1,000 meters where both tanks had lethal capability. The Panther's sophisticated fire control provided minimal advantage when Soviet crews could simply close the range and engage at point-blank distances where even crude optics sufficed for target acquisition. More critically, the report documented mechanical failure rates that made Panthers tactical liabilities rather than assets. German units abandoned Panthers due to engine failure, transmission breakdown, or final drive damage at rates that shocked Soviet analysts accustomed to T-34 reliability issues. A tank that could not reach the battlefield or survive the approach march contributed nothing to combat effectiveness, regardless of its paper specifications. Becker's remaining Panthers face the eternal dilemma of German armor on the Eastern Front: stand and fight against overwhelming numbers with equipment already compromised by mechanical failure, or retreat, consuming precious fuel and accelerating component wear that brings a catastrophic breakdown ever closer. The decision gets made for him when Panther II's final drive fails completely during attempted repositioning. The tank lurches to a halt, transmission locked solid by shattered gears that have destroyed themselves through thermal stress and overload. The crew abandons their disabled vehicle, carrying essential equipment across frozen ground toward German lines increasingly distant. All units, withdraw by sections. Panther 3 and 4, cover the movement. We cannot hold this position, Becker transmits, accepting tactical defeat. The withdrawal becomes a nightmare of mechanical attrition. Panthers designed for aggressive maneuver warfare must instead execute careful retreats that minimize stress on failing components. Maximum speed becomes irrelevant when exceeding 15 km/h risks terminal breakdown. The tactical mobility that German doctrine demands proves impossible when equipment betrays crews at every opportunity. Panther 3 loses its transmission during the first kilometre of retreat. The crew attempts emergency repairs, but winter cold makes even simple maintenance impossible. Bare metal freezes, exposed skin on contact. Tools become painful to hold, even through gloves. The complex procedures for transmission removal require hours in heated workshops with specialized equipment, not desperate field expeditions in -40-degree conditions. The crew destroys Panther 3 with demolition charges rather than allow its capture. Soviet technical intelligence has captured enough Panthers to understand their weaknesses intimately. Another intact vehicle would provide no useful intelligence and might even be pressed into service against German forces if Soviet workshops could source replacement parts. Becker's company returns to German lines with 4 of 8 Panthers operational. The survivors show signs of impending mechanical failure that will require extensive depot-level maintenance. Final drives emit ominous grinding sounds, indicating imminent catastrophic failure. Transmissions leak fluid from seals damaged by thermal cycling. Engines consume oil at rates that indicate cylinder wear far beyond acceptable parameters. In the warm confines of division headquarters, staff officers mark the action as a successful defensive engagement. German forces traded 8 Panthers for estimated 15 to 20 T-34 kills, a favorable exchange ratio by arithmetic standards. But arithmetic fails to account for the strategic reality that Soviet tank losses get replaced within days, while German Panthers take months to rebuild or replace. The fundamental asymmetry of the Eastern Front had become impossible to ignore by early 1944. Germany could build superior individual tanks, but lacked industrial capacity to produce them in decisive numbers. Each Panther represented months of skilled labor, specialized materials, and manufacturing capacity strained beyond sustainability. Each T-34 came off assembly lines optimized for quantity over quality, produced by workers who learned tank assembly in weeks rather than years. Quality versus quantity remains a false dichotomy when the quantity side achieves adequacy. The T-34 was not as well armored as the Panther. Its gun had less penetration. Its optics were inferior. Its crew accommodations were cramped and uncomfortable, but it could start reliably in -40-degree cold. Its wide tracks provided mobility across terrain that stopped German armor. Its simple mechanics could be maintained by ordinary soldiers rather than specialized technicians. Most importantly, T-34 seconds arrived at the front in numbers that allowed Soviet commanders to accept casualties that would cripple German forces. Lose 5 T-34 seconds to kill 1 Panther. Soviet doctrine considered that an acceptable trade when factories delivered 1,300 replacements every month. German forces had no answer for opponents who could absorb losses at rates that would constitute strategic disaster for the Wehrmacht. Friedrich Becker survived 1944 only to see his company's strength decline from constant mechanical attrition. By war's end, he commanded 3 Panthers, all showing signs of terminal wear that depot facilities could no longer repair. The sophisticated machines that were supposed to restore German armor superiority had instead demonstrated the futility of technical excellence without industrial capacity to sustain it. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The lesson embedded in winter warfare between Panthers and T-34 seconds transcended tactical or technical considerations. Modern industrial conflict demands weapons that can be produced quickly, maintained easily, and operated reliably under the worst possible conditions. The side that masters this reality wins regardless of individual technical superiority in specific engagements. Germany's Panther tanks never overcame their fundamental contradiction: excellent firepower and protection, compromised by mechanical unreliability that made them tactical liabilities when operating outside optimal conditions. Soviet T-34s embraced different priorities. Adequate firepower and protection, combined with rugged reliability that made them decisive weapons across all seasons and terrain. The -40-degree Russian winter revealed these choices with brutal clarity. One tank force could fight, the other could barely move. The winter of 1944 through 45 brought new depths of mechanical desperation to German Panther crews. Operation Bagration, the massive Soviet summer offensive of 1944, had destroyed 28 German divisions and pushed Wehrmacht forces back hundreds of kilometers. By autumn, German armor faced impossible tactical situations where mechanical reliability mattered more than any other factor. Unteroffizier Werner Vogel joined a Panther crew in October 1944 after his previous tank, a Panzer IV, was destroyed near Minsk. His first impression of the Panther combined awe at its firepower with growing concern about the mechanical issues veteran crews discussed openly. These were not the confident tankers of 1943 who believed German engineering superiority would prevail. These were exhausted soldiers who had watched mechanical failure kill more Panthers than enemy action. "The final drive will fail within 500 kilometers, his commander warned during Vogel's first briefing. "The transmission probably won't last 1,000. We can't get replacement parts. When something breaks, we abandon the tank and retreat on foot." That's the reality now. The statistics supported this grim assessment. German Panther operational readiness rates, which had improved to 54% by mid-1944, collapsed again as spare parts production plummeted. Allied bombing campaigns targeted German manufacturing facilities systematically. The Maybach engine plant was bombed in April 1944, halting production for 5 months. Panther assembly facilities faced repeated attacks that destroyed not just completed vehicles, but the specialized tooling required for component manufacture. By late 1944, spare parts production had fallen to 8% of tank production, down from 25 to 30% in 1943. This meant that for every Panther rolling off assembly lines, only a tiny fraction of the replacement components needed to sustain it in combat reached the front. German armor units cannibalized disabled tanks for parts, creating a downward spiral where mechanical failures led to more mechanical failures. Soviet T-34 production, by contrast, had achieved remarkable consistency. The simplified manufacturing processes developed during the desperate days of 1941 and 42 now paid dividends. Workers who learned tank assembly in weeks could maintain production even as experienced technicians were drafted into combat units. Quality had improved dramatically from the crude standards of early war production, while maintaining the high output rates that gave Soviet commanders numerical superiority. The T-3485, entering service in early 1944, addressed the firepower deficit that had made earlier models vulnerable to Panthers and Tigers. The 85mm ZSS-53 gun could penetrate Panther side armor at typical combat ranges of 500 to 1,000 meters. While still unable to reliably penetrate frontal armor except at close range, the improved gun made T-3485s dangerous opponents rather than helpless targets. More importantly, the T-3485 retained all the mechanical advantages that made its predecessors effective winter warfare platforms. The V2-34 diesel engine, the wide tracks, the compressed air starting system, all the features developed through bitter experience remained unchanged. Soviet engineers resisted the temptation to add complexity, understanding that reliability under harsh conditions mattered more than technical sophistication. Vogel's first winter operation came in late December 1944 during desperate German defensive fighting in Hungary. His Panther, part of a depleted company supporting infantry positions near Lake Balaton, faced the familiar challenges of extreme cold, combined with new complications from worn components and inadequate maintenance. The temperature dropped to -32 degrees Celsius on Christmas morning. Vogel's crew spent 2 hours attempting to start their Panther before finally achieving ignition. The battery, already weakened from months of service without replacement, barely provided enough voltage. The fuel, cut with gasoline to prevent gelling, burned inefficiently and created carbon deposits that fouled spark plugs and clogged fuel injectors. When the engine finally caught, it ran so roughly that the entire tank vibrated. Cylinder misfiring indicated valve timing issues that required depot-level maintenance to correct. But German depot facilities were either destroyed by bombing or captured by advancing Soviet forces. The workshop companies attached to panzer divisions lacked parts, tools, and increasingly the skilled personnel needed to perform complex repairs. "We keep it running or we abandon it," Vogel's commander stated flatly. "Those are the only options now." The tactical situation in Hungary demonstrated how mechanical attrition had undermined German armour doctrine completely. Panthers that should have formed mobile reserves for counterattacks instead sat in static defensive positions because movement risked catastrophic breakdown. The operational mobility that defined panzer warfare had been sacrificed to mechanical limitations that reduced sophisticated tanks to expensive pillboxes. Soviet forces exploited this paralysis systematically. T-34 85 seconds maneuvered freely, exploiting gaps in German lines while Panthers remained tied to defensive positions. The wide tracks that provided mobility across frozen ground allowed Soviet armour to attack from unexpected directions. German infantry, lacking adequate anti-tank weapons, called desperately for Panther support that could not arrive, because mechanical failures had immobilized the tanks before they could respond. Vogel's first combat engagement as a Panther gunner occurred on January 2, 1945. 3 T-34 85 seconds appeared at dawn, advancing across frozen fields toward German infantry positions. The range was 900 meters, well within the Panther's theoretical engagement envelope. In training, this would have been a simple gunnery problem with predictable outcome. Reality proved far more complicated. The frozen manual turret traverse moved, grudgingly, requiring full effort from both gunner and commander to achieve target alignment. By the time Vogel lined up his first shot, the T-34 seconds had closed to 700 meters and dispersed into tactical formation that complicated engagement priorities. The first shot missed when recoil shock caused the gun to jump more violently than expected. Cold metal contracted differently than in temperate conditions, changing the weapon's harmonics in ways that invalidated peacetime ballistic tables. The second shot struck but failed to penetrate when the shell, stored in extreme cold, performed below design specifications. Thermal stress had created microfractures in the projectile body that weakened structural integrity. The third shot achieved penetration, destroying the lead T-34 85 inches, a catastrophic ammunition detonation that sent the turret skyward. But the surviving Soviet tanks had closed to 400 meters and engaged from flanking positions that exploited the Panthers' weak side armor. One 85mm shell penetrated the fighting compartment, killing the loader instantly and wounding the radio operator. Vogel's commander ordered immediate withdrawal before the T-34 seconds could achieve killing position. But the transmission, already stressed by cold and wear, refused to engage reverse gear. The synchronizers, worn beyond specification and operating with degraded lubricants, could not mesh properly. The Panther sat immobilized, unable to retreat, unable to effectively engage multiple threats. "Abandon tank. All crew out." The order came as a T-34 maneuvered for a side shot that would prove lethal. Vogel dragged himself through the commander's hatch as the Soviet gunner fired. The explosion that followed destroyed his Panther completely, the ammunition detonation ensuring nothing useful would remain for Soviet salvage teams. The crew, minus their dead loader, retreated on foot across frozen ground toward German lines 300 meters distant. This pattern repeated across the Eastern Front throughout the final winter of war. Panthers that should have formed the backbone of German armoured defence instead became death traps for crews operating equipment that betrayed them systematically. The mechanical reliability that Soviet tanks demonstrated became the decisive factor in engagements where German technical superiority meant nothing. The final battle statistics told a story that transcended individual engagements. Between September 1944 and May 1945, frontline Panther strength peaked at 2,304 tanks, but losses in that same period exceeded 692 vehicles monthly. German industry could not replace losses even when factories remained operational. Allied bombing had shattered the supply chains, destroyed component manufacturers, and eliminated the skilled workers needed for precision assembly. Soviet T-34 production continued unabated. Factories beyond the Urals, relocated during the desperate days of 1941, operated around the clock, producing tanks that might lack polish but functioned reliably under the worst conditions. The simplified design allowed rapid production using workers with minimal training. The robust engineering meant that even poorly made T-34 seconds could reach the battlefield and contribute to operations. The asymmetry that had plagued German forces since Kursk reached its inevitable conclusion. Quality could not overcome quantity when the quality came with mechanical unreliability that prevented it from reaching the battlefield. Technical superiority meant nothing when sophisticated systems failed in the conditions where they had to operate. Werner Vogel survived 3 more Panther assignments before war's end. Each tank lasted less than 100 kilometers before mechanical failure forced abandonment. Final drives disintegrated under stress they were never designed to handle. Transmission seized from lack of proper lubricants. Engines wore out prematurely because maintenance procedures could not be performed without specialized equipment and replacement parts that no longer existed. He watched the Eastern Front collapse not from enemy action but from mechanical attrition that made sustained operations impossible. German armor doctrine required mobility, concentration of force, and rapid maneuver. Panthers immobilized by mechanical failure could provide none of these capabilities. The tank that was supposed to restore German armor superiority had instead become symbolic of the broader strategic failure. The comparison with T-34 performance grew starker as winter progressed. Soviet tanks continued operating in conditions that would have immobilized the entire Wehrmacht panzer force in 1941. The wide tracks, diesel engines, and compressed air starters that seemed like minor details in peacetime proved decisive under war's harsh realities. German engineers had known about Soviet winter advantages since the 1941 campaign. Guderian himself had written detailed reports on T-34 superiority in cold weather mobility, but German industrial capacity, already strained, could not redesign and reproduce the Panther with features necessary for reliable winter operation. The MAN design that won the Panther contract prioritized rapid production over the diesel engine and wide tracks that would have improved winter performance. This represented a fundamental failure in strategic thinking. German planners knew they would fight winter campaigns in Russia. They knew Soviet tanks performed better in cold weather. But they chose a design that sacrificed winter reliability for expedient production timelines. The result was a tank that performed brilliantly in optimal conditions and catastrophically in the conditions where it actually had to fight. The final irony of Panther versus T-34 winter warfare came in understanding what each tank revealed about its parent nation's approach to industrial conflict. Germany pursued technical excellence, sophisticated engineering, and individual superiority. The Panther embodied these values: powerful gun, strong armor, advanced systems. But sophistication required specialized manufacturing, skilled labor, and complex maintenance that could not be sustained under wartime conditions. The Soviet Union embraced different priorities. The T-34 was crude by German standards. Its armor welds were rough, its manufacturing tolerances were loose, its interior accommodations were Spartan. But it could be produced quickly by workers with minimal training. It could be maintained by ordinary soldiers using basic tools. And critically, it could operate reliably in the extreme conditions of the Eastern Front. By war's end, over 57,000 T-34 seconds of all variants had rolled off Soviet assembly lines, German Panther production totaled approximately 6,000 tanks. Even if Panthers achieved the optimistic kill ratios, German propaganda claimed, simple arithmetic made strategic defeat inevitable. The industrial base that could produce 9 T-34 seconds for every Panther ensured that quantity would eventually overwhelm quality. The temperature on the day Germany surrendered registered -5 degrees Celsius in Berlin, mild by Eastern Front standards, but cold enough to remind any surviving Panther crewmen of the mechanical nightmares they had endured. The frozen lubricants, the failing final drives, the transmissions that disintegrated under stress, all the technical failures that had undermined Germany's most sophisticated tank. Soviet T-34 seconds rolled through Berlin streets that May, their wide tracks gripping cobblestones that would have challenged narrower German treads. The diesel engines that had started reliably in -40-degree cold now powered the machines that captured Hitler's capital. The compressed air systems, the simplified mechanics, all the features German engineers had dismissed as crude, had proven decisive in the war's final accounting. The lesson of German tankers facing T-34 seconds in -40-degree Russian winter transcended specific technical details. Modern warfare rewards systems that can be produced in quantity, maintained easily, and operated reliably under worst-case conditions. Individual technical superiority means nothing when it comes packaged with mechanical unreliability that prevents the weapons from reaching the battlefield or surviving long enough to matter. The Panther was an excellent tank that could not be produced in adequate numbers, could not be maintained with available resources, and could not operate reliably in the conditions where it had to fight. The T-34 was an adequate tank that could be manufactured by the thousands, serviced by ordinary soldiers, and depended upon to start when needed and move where required. In -40-degree cold, adequacy overwhelmed excellence. Reliability, a defeated sophistication. The tank that could fight mattered more than the tank that should have won. Klaus Richter, Friedrich Becker, and Werner Vogel all survived the war to face different fates. Richter spent 5 years in Soviet prisoner camps, enduring conditions that made combat seem merciful by comparison. Becker died in American captivity from wounds sustained during the final retreat. Vogel returned to Germany to find his hometown destroyed by Allied bombing, the industrial infrastructure that had produced Panthers reduced to rubble. They shared memories of machines that betrayed them when they needed reliability most. The grinding sound of final drives disintegrating, the refusal of frozen engines to start, the transmission failures that immobilized tanks at critical moments. These mechanical nightmares haunted their dreams more vividly than enemy fire. Each man had witnessed the fundamental asymmetry that doomed German armor on the Eastern Front. For every Panther that broke down, a T-34 kept running. For every German tank abandoned due to mechanical failure, 3 Soviet tanks advanced to replace the one destroyed. The mathematics of industrial attrition favored the side that could sustain operations regardless of conditions. The historical record supports their memories with unforgiving statistics. Panther operational readiness rates never exceeded 54% at their peak and often fell below 40%. T-34 reliability improved steadily throughout the war, with later models achieving operational rates exceeding 80%. German Panthers were abandoned in their thousands during retreats, not from combat damage, but from mechanical failures that could not be repaired without parts and facilities that no longer existed. Soviet forces captured hundreds of Panthers during the war's final year. Technical intelligence teams examined these vehicles exhaustively, documenting the sophisticated engineering and the catastrophic mechanical failures. The reports noted with clinical precision how German pursuit of technical excellence had created weapons too complex to maintain, too fragile to operate under harsh conditions, and too expensive to produce in decisive numbers. One report summarized the lesson with stark clarity. The German Panther represents advanced engineering applied without understanding of operational requirements. The T-34 represents adequate engineering applied with complete understanding of actual battlefield conditions. In sustained conflict, The latter approach proved superior. The German tankers, who never expected T-34 seconds to outrun Panthers in -40-degree cold, had learned this lesson through experience more bitter than any technical report could convey. They had felt transmissions seize beneath their hands. They had heard final drives disintegrate while enemy tanks maneuvered freely. They had watched superior firepower become irrelevant when mechanical failure prevented engagement. The winter that should have favored German technology instead exposed its fatal vulnerabilities. Cold weather that German engineers had understood theoretically since 1941 was never adequately addressed in Panther design. The rushed development timeline, the political pressures, the industrial constraints, all combined to produce a tank that prioritized performance specifications over operational reliability. Soviet engineers, by contrast, had designed the T-34 from the beginning to operate in Russian conditions. Every feature, from the diesel engine to the wide tracks, emerged from practical experience rather than theoretical calculations. The compressed air starting system, added after bitter experience in the 1941 winter, exemplified Soviet willingness to modify designs based on battlefield feedback. This difference in design philosophy ultimately determined the outcome of armoured warfare on the Eastern Front. Germany built tanks for the war it wanted to fight. The Soviet Union built tanks for the war it was actually fighting. When those two approaches collided in -40-degree cold, reliability defeated sophistication every time. The frozen steppes of Russia, where temperatures plunge beyond what European engineering anticipated, became the graveyard of German armour doctrine. Not because Soviet tanks were better in any absolute sense, not because German crews lacked skill or courage, but because mechanical reliability in extreme conditions mattered more than any other factor when sustained operations determined strategic outcomes. German tankers learned to dread the sound of grinding metal that announced final drive failure. They learned to hate the refusal of frozen engines to start. They learned that superior firepower meant nothing when mechanical breakdown prevented them from engaging the enemy. These lessons came too late to change the war's outcome, but early enough to haunt survivors for the rest of their lives. The T-34 seconds that outran Panthers in -40-degree cold were not superior tanks by German engineering standards. They were simpler, cruder, less sophisticated, but they could start reliably when German tanks could not. They could maneuver when Panther final drives disintegrated. They could sustain operations while German crews abandoned mechanically failed vehicles. In the final accounting, that was all that mattered. The tank that could fight defeated the tank that should have won, but could not reach the battlefield. The mechanical reliability that German engineers had sacrificed for performance specifications proved more valuable than the performance specifications themselves. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.